So this question asks, for each of the following, identify the problem, if any, with the quantum numbers. So we're given the four quantum numbers, the principal quantum number, the angular momentum quantum number, the magnetic quantum number, and the spin quantum number. And there are rules for what these quantum numbers can be relative to one another. And it's important to note that these rules for the individual quantum numbers are with regards to where an electron possibly could be. But any individual electron will have four quantum numbers exactly, and no two electrons can have the same four quantum numbers. So in this question, we're asked about the general rules for what quantum numbers can be relative to each other, and then in future questions, we might be asked something different. We will be. All right, so n, the principal quantum number, can be 1 to infinity, and it has to be an integer. L, the angular momentum quantum number, is from 0 all the way to n minus 1. And again, it has to be an integer. The magnetic quantum number, m sub L, is from negative L through 0 to plus L. And again, it has to be integer. It can be a negative integer. And m sub S is either plus 1/2 or minus 1/2, spin up or spin down. So these are the possible values of the quantum numbers. So before we get into these, let's just take an example. Let's say that n equals 3. If n equals 3, the possible values of L are 0, 1, and 2. 0 to n minus 1. So 0, 1, and 2, because 3 minus 1 is 2. The values of m sub L vary based on L. So if L is equal to 0, the values of m sub L has to be 0. Negative 0 through 0 to positive 0, so just 0. If L is equal to 1, it's minus 1 to 0 to 1. All right, this is because negative 1, 0, and 1. And for 2, it's the same thing, negative 2, negative 1, 0, 1, and 2. So this is an s orbital, and there's one s orbital, right? Because L is equal to 0, and the only m sub L is 0. This is a p orbital, and there are three p orbitals, the negative 1, the 0, and the 1, or the px, the py, and the pz. And then this is a d orbital, and there are 5 d orbitals. So these two things are related. These are the possible locations of electrons. In all cases, m sub s could be plus or minus 1/2 for this one, this one, this one, this one, this one. All of them can have an m sub s value of plus or minus 1/2. Said another way, you could fit 2 electrons in every orbital. One that's plus 1/2 and one that's minus 1/2. So I'm not going to write plus or minus 1/2 50 times, but it's plus or minus 1/2 for every single one of these. So these are 4 coordinates of electrons within an atom. Just like if you want to give your coordinates, you could give them in terms of latitude, longitude, okay, so where you are geographically on the Earth. Altitude, I happen to be on the 3rd floor right now, but if somebody was on the 2nd floor, okay, they could have the same latitude and longitude, but a different altitude than me. And also time. Right? If you're going to meet somebody somewhere, usually you don't tell them the latitude, longitude, and altitude, right? You might say, meet me at Starbucks, but you also need to tell them when. So there are 4 coordinates to describe where a person is. There are 4 coordinates that describe where an atom is. The principal quantum number, the angular momentum quantum number, the magnetic, and the spin quantum numbers. And these are the possible values. All right, now that we have that out of the way, let's actually answer the question. It says for each of the following, identify the problem, if any, with the quantum numbers. So if n equals 1, the only possible value of L is 0. So L has to equal 0, so that's a problem. We can just stop there because once there's a problem here, you're just continuing to have problems moving forward. If n equals 3, the possible values of L are 0, 1, and 2. In this case, 1 is a valid value. If L is equal to 1, the possible values of m sub L are minus 1, 0, and 1. It can't be equal to negative 2. So there's your problem. If n equals 3, L could equal 0. It could equal 0, 1, or 2. If L equals 0, M sub L has to equal 0, because remember, M sub L is negative L through 0 to positive L, so negative 0 to 0 to positive 0, so just 0. So if L equals 0, M sub L is 0. M sub S can either be plus or minus a half, so this one doesn't have any problems. N equals 1, L can equal 0, in fact L must equal 0. If L equals 0, M sub L must equal 0 because it's negative 0 to 0 to positive 0, which is just 0. It can't be negative 1. So the first, second, and fourth choices have mistakes, and the third choice doesn't have any problems.